Hi friends, is my voice is audible to you? My voice is audible, and if everything is fine, please let me know. Okay, so today's session is all about second part of columns from summary of IS 456 2000. The concept is about IS 456 2000 summary. In that one, the topic is second part of columns. Today, that we are going to tackle. Right. Before I start the session, I just want to convey one thing. There is so much of free content is already happening in this Unacademy learning app. So if you are a serious aspirant of GATE or ESE or any other competitive examination, then definitely I can recommend you guys to install this Unacademy learning. Okay? Right. Hope you are fine and everything is working well to you. Right. Let me have a check. If you are in online, please say a hi so that I will also understand like you people are in online. Okay, right. Okay, second. Yeah. Okay. Okay. So I hope you had already known like Unacademy Combat for Gate is happening on 16th December. So register for that one in Unacademy Learning app using the code Combat now. Now before I start the session, if you are a serious aspirant of GATE or ESA, I can definitely recommend you to install this Unacademy Learning. Right after you install this Unacademy Learning app, you are able to access, you are able to follow me by using this link which is given below. When you press down this link, you guys will be redirected to my home page or my profile page. If you are able to follow my profile page, then definitely the future coming videos, there are three advantages are there if you are able to follow me. The first one is already free content done by me for free of cost in an Academy Learning app. You are able to access the future coming free videos of mine that are going to happen in an Academy learning app will be right to you. And the third advantage is at the end of each and every session, we are going to provide a free notes to you. That is also for free of cost. These are the three advantages when you are able to follow me without paying a single penny. So this is the advantage, brother, when you are able to follow me. Some people will say like, sir, is there any paid courses also there in an Academy learning app? Yes, brother, there are so many paid courses are there in an Academy learning app. Uh, After you install this Unacademy learning app, select your goal or target as GATE and ESE. This is the goal, whatever we want to achieve. And after you select, this is the goal. And in the search button, uh, and in the search, before you go to the search button, there is a tab called main tab. In the main tab, go to plus courses. After you go to plus courses in the main tab, you are able to see a what I can say a tab called get subscription. When you press on this get subscription, then definitely you guys will be reader. You guys are interested. That shows that you are interested in paid course. So when you press this get subscription, you will be redirected to a page which is having two courses, which is shown with two courses like plus course and iconic course, right? So when you had taken the subscription either for plus course or iconic course, then definitely you will be taught by India's topmost faculty, and moreover I can say you will be provided with unlimited access for live and recorded versions for all the courses that are provided by Unacademy in your particular stream, right? And if you want to get 10 percentage for the courses of plus course or iconic course or any of the things, to get 10 percentage discount, you are bound to use this code VT10, brother. Okay, like, so some people will say like, sir, that is fine. Okay, so before you start the session, how to purchase that course, what are the importance of that course, and okay, actually before going to the free content, so please introduce yourself. Some people will say, yes, I am Venkata Tilak Kopalapati. People call me as Venkata sir. Some people call me as Tilak sir. I completed my master's degree from University of Sheffield, England, and about to complete my doctoral degree also. My background of education is completely into structural engineering. So here also in an academy platform, I am going to teach only the structural subjects ranging from engineering mechanics, strength of materials, structural analysis, concrete structures, steel structures, and finally to construction materials. This university has produced six Nobel Prize winners, brother. So producing six Nobel Prize winners is not a joke. You can understand the depth of research potentiality involved in that university. One thing. And second thing about this university is the ranking of this university is always far better than IITs and IISc Bangalore. The ranking of this university is less than 100 globally, which is far better than IITs and IISc Bangalore. So some people will also ask us, sir, what is your previous work experience other than teaching? Previously, I worked as a research scientist or research engineer in University of South Carolina for a funded project. This is in USA. For the same funded project, I worked as a team lead position also. Moreover, previously I worked as head of the Department of Civil Engineering in an engineering college called as TEN. This is in Andhra Pradesh, India. It shows like I have within India experience and outside of India global experience also. Being a structural engineer, even till today also I am working as an independent structural design consultant. I personally give structural drawings to my clients and material testing reports to my clients. Material testing reports. These are work I do as a design consultant. And coming to my teaching experience, totally I have 12 years of teaching experience, brother, in teaching different coaching institutes all across India. I had mentored more than lakhs of students till now, and this is my brief profile, brother. Okay, let me start teaching you, right? What let Before I start teaching you the actual content of today's session, I just want to say like some people will also ask us, sir, how to install this Unacademy Learning. So after you download this, go to Play Store. Go to Play Store, and after in the Play Store you type this name Unacademy Learning App. When you type this name Unacademy Learning App, you guys are able to see a championship type of trophy in this way, and you can install that app. After you install that app, you can also follow me. Some people will say, sir, how we can follow you? Using this link, if you press this link directly, you are able to follow me. Okay. Some people will say, sir, without this link, is there any procedure? Is there how we can follow you? Yes. So this is the main tab. In the main tab, go to free courses. After you go to free courses in the main tab, in this search button, you type my name completely, Venkata Tilak Uppalapati. When you type my name Venkatathila Gopalapati, my profile page will be visible to you. When my profile page is visible to you, you just follow me. This is how you can follow me, brother. Some people will come and say like, okay sir, that is fine. Now you tell me how we can register for the paid course, how we can take the subscription. To take the subscription, after you install this Unacademy Learning app, this is the main tab. Na? After you select this target as GATE and ESE, from the main tab, go to plus courses. After you type this name plus courses, you are able to see a tab called Get Subscription. You press on Get Subscription. Then when you press on this Get Subscription, it shows like you are interested in take the paid course. Okay, fine. Now how the screen will appear before you when you are able to press this Get Subscription, I just want to show with the help of screenshot. Is that okay? Right. Moving to how the screen will appear to you when you press on this Get Subscription. I hope you in this way you are able to see the screen. There are two courses or paid courses are there. One is plus course and second one is iconic course. We are talking right now about the plus course finance, financial terms. If you want to take 12 months duration of paid course in plus, the cost is the cost after 10% discount is 27,225. That is one thing. And one more thing I just want to convey, like to get 10 percentage discount, what you should do, here in this referral code, you need to type this VT10 and you need to say proceed to pay. When you say that one, definitely when you use this code VT10, definitely 10 percentage discount will directly come to you on all the courses, brother. One thing. And moreover, it shows your trust on me. It will directly connect between you and me when you are able to use this code VT10. One thing. And some people will also ask us, sir, is there any EMI option is available? I can say EMI option is also available on subscription if you had taken the subscription more than or equal to 6 months. So on these 6 months duration to 24 months duration, even no cost EMI is also applicable, brother. So there is no need to pay for you all the payment at a single time, right? And if it is an iconic course, then definitely I can recommend you guys to use this code uh, for this iconic course. After applying this VT10 code, the cost for this 12 months duration of iconic course is 45,225. Right, I can recommend this 12 months course for the students who are in final year, whereas I can recommend this 24 months course for the students who are in third year or second year. Right. For any of the course to get 10 percentage discount, you are bound to use VT10 code and you need to say proceed to pay. I hope you understood how to take the paid course. Some people will say like, sir, what are the advantages if I had taken the paid course? That is our main interest, sir. Okay, let me tell you what you will get when you had taken the paid course. The paid course may be plus course or iconic course. Advantages. The first and foremost advantage is instant doubt resolution is possible when you had taken the paid course. You can directly chat with the educator and the educator will resolve all your doubts and answer all your doubts with the help of polls while the class is going on. That is the first and foremost advantage when you had taken the paid course. Right. Second advantage is in order to crack any sort of competitive examination, you should be provided with the support of test series. So here also in Unacademy, we are doing the same. We are providing the support of test series, and in the test series, the test will be given in terms of quizzes, diary wise test, mock test, grand test, subject wise test. If you write all those tests, you will understand at what level you people are in terms of performance, and you can analyze your performance when compared to the topmost students of an academy. So definitely, if you are lagging your performance in terms of marks or score in some of the areas, you can definitely improve your performance by working on that particular topic for more lectures, and by writing more mock tests in that particular area. This is how you can improve your performance. Coming to the third advantage is there is no need to plan yourself, brother. We will provide the each and every plan. If you stick to that plan, definitely we are pretty much sure like you are able to crack any sort of competitive examination for sure. We frame the courses in such a way that the syllabus will be as per the latest syllabus of GATE and ESE, and we will frame the number of lectures in such a way that even the below average student can cope up with our lectures. If you are able to stick down to our plan and if you are able to complete all the test series, then you are when we are pretty much sure like you are able to crack any sort of competitive examination for sure in civil engineering. And moreover, the last advantage is you will be provided with unlimited access to all the recorded versions and live classes when you had taken the subscription. Maybe that that access will be given to you maybe by using with the help of mobile phone, or maybe a PC, or maybe a laptop, or maybe a tab, depending on your comfort. You will be provided with the access to your devices. Okay, these are the four advantages which will make you ready to crack any sort of competitive exam. There is course called Iconic, for which there are two more added advantages are there. There is a separate mentor for you, so he will track all your performance, and he will resolve all your doubts regarding the subject, and also how to work on your things to get better rank. And in addition to this one, you will be provided with a PDF notes, especially from Unacademy, when you had taken this iconic course. Special notes from Unacademy. These are the advantages. These are two extra advantages when you had taken the iconic course. Iconic course is more superior than this plus course, right? Some people, I just want to convey one more thing. These are some of the faculty, topmost faculty that we have directly in an academy learning app. You can have a look directly in the app itself. I just Moreover, the classes will be taught separately in English and also in Hindi, so there won't be any language barrier also. Those guys who are comfortable in English, they can attend English classes. Guys who are comfortable with Hindi, those people can join Hindi classes. So there won't be any language barrier also for you. Coming to GATE and ESE, till now in GATE and ESE, we people had launched 8 courses. Out of these 8 courses, few courses are long-term courses, few courses are short-term courses. Few courses are, I can say, like in English, few courses are in Hindi. When you had taken the paid course, brother, you will be given access to all the courses that are launched by an academy in your particular stream, like civil engineering. And moreover, you will be provided access for the courses that are going to be launched after you had taken the subscription. Depending on the duration of subscription, you will be provided access even for these courses also, right? Last but not least, I just want to convey, every day my classes are happening in this Let's Crack Gate and ESC Civil YouTube channel. My class is happening every day by 11 a.m. So I can say, like, don't forget to come down to my class, brother. And even I can also recommend Kamalakar Pandey sir classes also to you. His timings of class every day is happening by 9 a.m. So you are getting all this for free of cost. So that's the reason why I am requesting you guys, please share our videos, subscribe to our videos, please press a thumb, please like our videos. When you like our videos, with more energy we can do more free content for you, which is beneficial for you guys. And moreover, share these videos to your friends so that they will also get benefited with this free content. And don't forget to press the bell icon, brother. When you press the bell icon, the future coming videos from this channel will be notified to. In such case, you will not miss even a single lecture that is coming out from this channel. Let's Crack Gate and ESE Civil YouTube channel. For your easiness, I already started a Telegram group, and the name of the Telegram group is Let's Crack Gate and ESC. And the other Telegram channel I had launched for you, which is Unacademy underscore Civil Engineering Tilak. If you come down to our channel, you can press this link which is given below. When you press this link which is given below, you guys will be redirected to my channel, and you can post your doubts directly in that channel. I will definitely respond to your doubts, brother. Right. So shall we start working out? Shall we start working out? Yes. Hi Vasan Sai. Hi Kasula Vijay. Hi, how are you? Hope you are fine. Right? Yes. Okay. Right. Shall we work out this session? Right. So today's session is columns 2. Right. Uh, uh, how to work out the effective length in case of columns? The effective length of columns is based on the type of support conditions. So based on the type of support conditions at the ends of column, the effective length of the column will depend. And coming to effective length, there are two types of effective length. One is the theoretical effective length, and second one is practical effective length. Some people will say, sir, what is when I will use this theoretical effective length, when I will use this practical effective. Okay, before I start teaching with the difference of these two, let me define what is this effective length. So how I can define this effective length, brother? Effective length definition. How I can define this effective length? It is the distance between points of two contra flexure. So I can say distance between, let me write, distance between points of two contra flexure, two adjacent contra flexure, or distance between points with zero bending moments. Distance between zero bending moment point. Distance between zero bending moment points. I can say like this: practical effective length is used during the time of design of columns. This practical effective length is the terminology generally we will use during the time of design of columns. During time of design of the columns, if I want to work out the slenderness ratio, in such case I need to consider this practical effective. Where you will use this theoretical effective length if I want to find out the load carrying capacity of the column. So if I want to find load carrying capacity of column, then I can use this theoretical effective. So both practical effective lengths and theoretical effective lengths are actually tabulated in, if you see, IS 456 2000. Now the question is, how to work out this theoretical effective length or practical effective length? Everybody will say, and moreover, some people will also ask us, sir, what is the importance of this effective length? So before I teach you how to work out this effective length, I just want to mention what is the importance of this effective length. Importance of effective length. This is useful in working out the slenderness ratio of the column. Useful in working out slenderness ratio of the columns. So how we can define the slenderness ratio of RC column? Lambda of RC column. Generally for RC column, it is effective length by least lateral dimension. This is how we can define for RC column. Least lateral dimension. Some people will say like, sir, how we can work out this lateral dimension, sir? So if you take a concrete column of cross section, maybe in this way, this is 250 millimeter, this is 400 millimeter, and this is having certain length. It is more like 3 meters. I find 3000. What is the least lateral dimension, least dimension of this column? The least dimension for this example for this column is 250. Na? In such case, effective length by least lateral dimension we can consider. And lambda for RC column, so based on this one, we can judge whether the column is a short column or a long column also we can judge. Right. Now the question is, sir, okay, fine. How we can consider or how you can evaluate the effective length of the column? That is the question. So coming to the effective length of the column, right here. Coming to the effective length of the column. So if one end is fixed, another end is hinged. So this is the things I can say which are the things which are there in the bracket are theoretical effective lengths, whereas this is practical effective. right? So if I apply a load, for example, in this, how the deformation sketch for this column, one end is hinged, another end is fixed. This is how a deformation sketch for the column because of axial load, right? This is how it can happen. At fixed support, it won't allow any sort of rotation. This is the point I want to show here. From here to here, for this type of bending, the tension is on this side. For this type of bending, the tension is on this side. If I draw a line here, tension for this span, this is A, B, C. For AB span, the tension is on the left hand side, okay. For BC span, the tension is on the right hand side. So in such case, I can keep this maximum bending is happening here, na? Here if I keep, and here the bending moment is 0. If I join, this is the bending moment diagram qualitatively. If I join, this is how the bending moment can be. Now, from this basic definition, is the distance between points of two contraflex, right? One is this is one zero bending moment point, then this is the bending moment where the bending moment is changing. So, if you can say like this, right? If this is the effective length, we this effective length. To refer to the code of practice highest 456 2000. In such case, the theoretical effective length is L by root. So, which is L effective theoretical. So which we put an order 0.707. Now some people will come and say, sir, what is the practical effective length? So coming to the practical effective length for this case, one end is fixed, another end is fixed. So in such case, the practical length is some bit higher than theoretical value. This is the note. Practical values of effective lengths are slightly increased than the theoretical value. The value which is more than 0.707 times of L. So in such case, practical effective length for this case, L effective practical is more than this one, 0.8 times of L. This is how we can consider. Now some people will come and say, sir, when both the ends of the column are fixed, sir, like this is fixed and this is fixed. In such case, how we can work out the effective length, right? In such case, this is how I can draw this sketch for this column for deformation because of axial load. Yes, you can see. Now from here, if this is A, this is B, this is C, this is D. For A to B, this is how the direction of this side tension is positive. From B to C in this direction, the tension is for B. After bending for CD segment on this direction, tension is positive. So obviously, if you try to draw the qualitative bending moment diagram, I just want to draw the qualitative bending moment. Okay. So can I rub for the first case? I'm just rubbing for the first case. So I do. If I do here, right? Yes. Here, if I draw a line from here to here, from in CD, the tension is on this left hand side. AB also tension is on the left hand. As in BC, tension is on the right hand side. Okay, if I draw a line joining this qualitative bending moment diagram, I am drawing the bending moment diagram on the tension side. That is the one and only, okay, that we are doing here. Okay, so if you take, this is the point of contra flexure, this is the point of contra. Distance between these two points is nothing but effective length. Effective length. The effective length is of, and both the ends of the column are, one end is fixed and also at the other end also it is fixed. And we can do this. Now the question is, Sir, what is this effective length? So coming to effective length, theoretical effective length. Theoretical effective length is 0.5 times of L for this case, whereas the practical effective length for this case is 0.65 times is L effective practical. This is how we can make. And coming to the next case, like when both the ends of the column are, I hope you are able to see a hinge, or here you are able to see a hinge. And both the ends of the column are supported by hinged connection. In such case, if because of this axial load, how the deformation of this column can happen because of this axial. To take this axial load, this is how the deformation sketch for column will happen when both ends of the column are hinged. Right? In this case, when you take this is the point of zero bending moment of zero bending from here to, if I draw this is nothing but effective length. That effective length is equal to L. So effective length is equal to L when uh, effective length is equal to L. Either it is theoretical effective length or practical effective length. The answer is L only when both the ends are hinged, right? When both the ends are hinged. And moving to the next type of condition, when one end is fixed and the another end is free. This is fixed. This is fixed free condition. When you draw this fixed free condition, I hope this is how you are able to see deformation sketch. So this is zero bending moment point. Maybe if I want to draw the bending moment sketch in this way, this is zero bending moment point. But I want another zero bending moment point also. So because of which, if I take a mirror image, this is how this bending moment diagram we can get because of mirror image. Now you can see, like, is there a distance between points of two contraflex? In case of this is one end is fixed, another end is free. Is a cantilever column. In case of cantilever column, how we can take the effect length equal to 2L. Either it is theoretical effective length or practical effective length. 2 times of L, right? Some people will say like, sir, in some people will also ask me a question, sir, okay, this is fine. In some of the cases, in some of the questions, they are not giving the type of the supports, but instead of saying type of the support, they are giving like how we can say about this type fixed support. Uh, Fixed support at the end or support when translational displacements are restrained, both translational and rotational displacements are restrained in all directions. Are restrained in all directions. You can call it as fixed. I hope some people will come and say how the hinged support is mentioned in this. So how we can say when the support is, for the case of hinged support, only it will allow rotation, but translational displacements are risk. So support condition at which translational displacements are restrained. Translational displacement are restrained, but only rotational displacements are allowed. But only rotational displacements rotational displacements are yellow. In such case is nothing but digits. Some people will come and say, what is the free end? And, and how the free end can be mentioned into this. There is this, how we can define this. At the free end, not even translational displacement is restrained, not even rotational displacement is also restrained, right? So, mm, at end at which both translational displacements and rotational displacements are allowed freely. In such case, it is nothing but free end. So either instead of the type of support, they may mention about the type of this in this way of verbal way also they may mention. So you need to pick the correct type of support from this statement. Okay. So moving to the next question, brother. I mean, next thing. But before I tackle about the next concept, there are certain few questions were there. So I am expecting answer from you guys. This is how the questions are there. So I hope you are able to see these questions. All 5 to 6 questions we had prepared, 5 questions, and those 5 questions are numerical questions. I am expecting answer from you, right? So coming to this question, the factored load carrying capacity of a column of 300 millimeter by 600 millimeter. So load carrying capacity of this column with minimum percentage of steel. So percentage of steel, minimum percentage of steel in compression. They are saying this PSE is the percentage of steel in compression. Minimum percentage of steel. What is the minimum percentage of steel? Generally, we need to use in columns. Minimum percentage of steel that we can use in columns is 0.8 percentage of cross sectional area. This is how we can do. Okay, they are expecting load carrying capacity of the column. How we can work out the load carrying capacity of this column? Right, the load carrying capacity of the column we can work out by taking FCK by 2.5 into area of concrete plus this 2.5 is the factor of safety in axial curve, and Fy by 1.5. This 1.5 is the factor of safety for steel in axial compression. So into area of steel compression. The basic way I can work out the load carrying capacity of, because if you take column, there are two materials are there. One is steel and another one is concrete, right? So steel will take some load, whereas concrete in axial compression will take some load. Load carrying capacity of these two materials combination is nothing but load carrying capacity of entire column. So can I work out this, brother? So it is FCK. FCK is 20. It is saying M20 and Fe4 and 5 steel. Na? So 20 by 2.5 into area of concrete. See what is the area of the concrete? Cross sectional area minus area of steel. Cross sectional area is 100%. And 100 minus from that one area of steel is 0.8%. So minus 0.8. So which we can call it as percentage of cross section area. So definitely it is 99.2 percentage area of cross section. 99.2 percentage of cross section. Cross section area is in such case 0.99 into 300 into 600. This is how we can mention, right? So AC 0.992 into 300 to 600. Is that okay? I'm expecting answer from you guys. Okay, plus what is the yield strength of the steel? The yield strength of the steel is Fe4 and 5. I can write 4 5 by 1.5 into ASE. area of steel in axial compression. Area of steel in axial compression is 0.8 percentage of cross. 0.8 percentage of the cross section area. How we can write? 0.8 by 100 into cross section area is 300 by 600. So if you are able to do this, it is yes. If you are able to do this one, the problem is over. What will be the answer, brother? If we add up this combination, it is 1828.87. We can write into 10 cube Newton. We can write. Coming to the answer, it is 1828.87 kilometers. So what is the correct option that I can go for, brother? Correct option that I can go is 1828.87. Correct option I can go option C. Is that okay? Shall I move to the next question? Moving to the next question. I hope you are able to see the next question also. The ultimate load carrying capacity of a circular section. To take a circular section, ultimate load carrying capacity of a circular section of 300 millimeter diameter is 300 millimeter. 300 millimeter diameter with helical reinforcement. They are saying with helical reinforcement using 1 percentage of reinforcement. They are saying with 1 percentage of reinforcement. They are saying area of steel compression 1 percentage of cross section. Okay, and they are saying FCK is 20 and FI is FE 415. This is how they are mentioning. Okay. Hope you are able to see. Ultimate load carrying capacity of circular section, okay, of 300 millimeter diameter with helical reinforcement using 1 percentage of. Okay, they are saying 1 percentage of. They are expecting load carrying capacity. So I just want to convey one more thing here. They are using helical reinforcement. When they are using helical reinforcement, the load carrying capacity of the column will be increased by 5% when the column is tied with helical reinforcement. So I can write PU, which is equal to PUZ, which is equal to load carrying capacity of the column, which is we can write as 1.05 times of cross sectional area, 1.5 times of right FCK by 2.5 into area of concrete plus permissible stress instantly Fy by 1.5 into area of steel in compression. How you can take the area of concrete if 1 percentage is steel, 99 percentage area cross sectional area of column. So in such case, you can directly write AC is 1 percentage of cross section, and in such case, what is the area of concrete is 99 percentage of cross. FCK FCK is 20 by 2.5 into area of concrete. Area of concrete is how much, brother? 99 percentage of cross is 0.99 into cross section. It is cross section area is 300 millimeter diameter circular column. So into pi by 4. This is for the first term. So plus FE 415 by 5 into area of steel compression. Area of steel compression is 1 percentage of cross. How we can write 0.0 times cross 300. Do this one. Why this 1.05 is extra multiplied? this 1.05 need to consider to increase the load, axial load, compression load carrying capacity, because the column is having the longitudinal parts of the column are tied together with the help of this spiral reinforcement. Due to spiral reinforcement, this load carrying capacity is increased by 5%. Circular column with helical reinforcement 1.05 taken 5% increase in load carrying capacity. 5% increase in load carrying capacity can say due to what? Due to, I can say, due to circular column with helical reinforcement or spiral reinforcement. To circular column with spiral or helical tie reinforcement. So if you do this one directly, what will be the answer? The answer will be definitely 794.2 into 10 cube Newton cube. If you want to mention this answer, we can, after converting this as kilonewton, the answer will be 794.2 kilonewton. This is by the final. Correct option that is matching is nearest option that is matching is only for Detroit will be the correct option. Is that okay, brothers? Is that okay? Shall I move to the next question? Is that okay? Can I move to the next question? Yes. Moving to the next question. I hope you are able to see a column. A reinforced concrete short column with 300 millimeter by 300 millimeter square is made of M20 concrete and has four bars of 20 millimeter diameter. Longitudinal bars of Fe415 steel. Okay, they are taking an RC short column 300 millimeter by is made of M20 grade concrete. They are saying it is CK is and has four numbers of 20 millimeter diameter longitude. So area of steel in question is four bars of longitudinal yield strength of is under the action of a concentric axial. Ignoring the reduction in, they are saying it is subjected to a concentric. There won't be in your previous in your previous questions also no talks were made on eccentricity. If the eccentricity was there, we need to consider as an axial load with uniaxial bending moment or biaxial bending moment. Need to consider. But it is a concentric axial compression load they are mentioned and ignoring the reduction in the area of concrete due to steel bars. Ignore the reduction in the area of concrete because of steel bars, the ultimate load carrying capacity of the short core. They are expecting what is the ultimate load carrying capacity of the short core. I think ASC is given. If ASC is given, what is area of concrete? Generally, I can write gross area minus ASC. But they are saying like reduction in the area of the concrete due to steel burst. So in such case, don't consider the reduction in area of concrete. Take the total area of concrete as gross cross section. AC is equal to gross cross section. Directly 300 is 300 square we can do. 300 square we can. In this case, how you can work out this? The load carry capacity PU is directly it is equal to we can directly write it as FCK by 2.5 into area of concrete. Area of concrete is 100 plus permissible stress of steel in compression. Permissible stress of steel in compression, axial compression by 1 point into area of steel into pi by 4 into 20. Right? I hope you know the answers of FCK. FCK is directly the field strength is do this directly the answer how much you are going to get it. The answer that you are going to get is definitely it is 1069.41 into 10 cube ton, which will be 1069 kilometer. 1069 kilonewton is the final option. Is that okay? Right? Shall I move to the next question, brother? Moving to the next question. A column of 600 millimeter by 450 millimeter. Okay. The effective length of the column is 3 meter. They are saying the effective length of the column is 3 meter. Okay, fine. Effective length is 3 meter. How this design of the column should be done as per IS4. And with respect to, I mean, if I say effective length by least lateral dimension with respect to shorter dimension. L effective by B, if I consider effective length is 3000 millimeter by least lateral dimension out of 600 and 450. The answer is 450. If I take it is 6.67, this is less than 12. I mean, okay, now I need to work out the slenderness ratio. Here they are asking you to work out the slenderness ratio with respect to uh, shorter direction and with respect to the longer direction of cross section. I can say this is with respect to shorter, the one axis is direction, another axis with respect to longer direction. So I can say next one is effective length by least dimension with respect to longer direction the cross section. The least dimension with respect to longer dimension is depth D. So which is 3000 millimeter by the effective depth is how much, brother? The effective depth is millimeter, so which is 5. It's also less than 12. So in such case, with respect to short direction, also it is short. With respect to short dimension, it is also short. With respect to short dimension, it is short column. Even with respect to long dimension, also it is short column. Right? So both with respect to long dimension and both with respect to short dimension, it is a short column only. So directly I can say short along long and short dimension. The short column along long and short dimension. Yes, I can say both are. I mean, with respect to both with respect to both longer dimension and shorter dimension, the column is turned as a short column only. So directly I can say like option A itself is the correct option. Shall I move to the next question, brothers? Shall I move to the next question? Yes. I hope you had seen this question. You are able to see this process. A reinforced concrete column contains longitudinal steel equal to 1 percentage of net cross sectional area of the column. So they are saying a reinforced concrete column consists longitudinal steel. So area of steel in compression is 1 percentage of net cross sectional area of the column. Net cross sectional area of the column is nothing but area of concrete. It is 1 percentage of area of concrete. So it is area of concrete by 100, right? Assume modular ratio as 10. M is equal to modular ratio, which we can define as Young's modulus of steel to Young's modulus of concrete. This ratio is assumed as 10. The loads carried using elastic theory by longitudinal steel and the net area of concrete. So the loads carried by steel and concrete. What is the ratio of load carried by steel to load carried by column? This ratio in terms of percentage. So in terms of percentage means they are expected to 100 is how much? What is in terms of percentage? So how you can write this PC and all this PS by PC and all this stuff? I just want to convey one thing here. The load carrying capacity can write. How I can write this load carrying capacity in terms of this modular ratio? I can write basically, I can write basically from strain compatible. Let me, the strain compatibility of steel rods and concrete, from the strain compatibility of steel rods and concrete. The strain in steel rods is equal to strain in concrete in case of columns, right? So here how we can write. If I take a concrete column and it is having certain steel rods, maybe these are the steel. So from from compatibility equation, we can write directly as a strain in steels is equal to strain in concrete. So strain in concrete equal to strain in steel. If it is in terms of axial strain in concrete, I can say axial compressive strain in concrete is equal to axial compressive strain in steel, and the lengths of concrete and steel rods are one and same here. In such case, the change in length of concrete is equal to change in length of steel. Directly we can write delta LC, change in length of concrete is equal to change in length of. Okay, so from this one, how we can write the axial axial compression of concrete, axial change in length of concrete. How we can write the axial change in length of concrete? So if let us suppose if PC is the load carrying capacity of concrete, load carrying capacity of, what is PS? Load shared by steel or load carrying capacity of steel. The total load is P. In such case, equal to PC plus PS. If I say how you can write the change in length for concrete, it is delta L is equal to PL by A. Here I can write it is PC into LC, PL by AC, area of concrete, AC into EC. Here I can write PS into LS by AS into how can do. So it is PC. How you can write this PC, brother? So PC, you let me write as PC unit. LC is L. What is this AC? AC we can write as AC. Young's modulus of concrete is EC. How you can write PS into LS is L. Or how you can write AS, brother? ASC. How you can write AS is equal to area of concrete by 100. This I had already clearly mentioned. Area of steel is equal to 1 percentage of net area. 1 percentage of net area means 1 percentage of area of concrete. So I can write instead of AS, I can write ASC by 100 into Young's modulus of steel. If you do this one, definitely we want PS by PC. LL will get cancelled. AC will get cancelled. So directly PS by PC you can write as Young's modulus of steel by Young's modulus of concrete uh, into uh, 1 by 100. So which is equal to ES by EC is called as modular ratio, right? Young's modulus of steel by Young's modulus of concrete is called as, this is modular ratio. So modular ratio by 100 is 10 by 100 is equal to zero point 0.1. But they are asking you guys, please understand, they are not just asking you the ratio of load carrying capacity of steel to column. But if you see the question, they are asking you the ratio of PS by PC expressed in terms of percentage. So expressed in terms of percentage means you need to, they are expecting you PS by PC into 100. So it is zero point 0.1 into 100. How much will be the answer? It is 10 percentage is the correct answer. So in terms of percentage, zero point 0.1 can be written as 10 percentage. So directly I can say like D for Detroit is the correct option. Is that okay? So shall I move to the next question, brothers? Right? Shall I move to the next question? I mean, next question is the next concept. Right? Moving to the next concept. Some people will say like, sir, you mentioned the effective length for columns. One second. Some people will say like, some people will say like, sir, you had teachers effective lengths for individual columns. Now the question is, sir, how to find out effective lengths of columns in case of rigid jointed framed structures? I can say simply the answer is not by considering it as one end fixed, another end is free. In this such case, the effective lengths of the columns in case of framed columns, we framed structures we can found by Wood's table. Where this Woods table is there, the Woods table is there in IS 456, IS 456 2000. I think appendix to refer, these Woods tables are there in appendix. Now, before the effective lengths of columns in case of framed structures, and especially some people will also ask us, are in case of RCC, if I want to make the moment of resistance of the section is zero in RCC, if I want to make a hinge in RCC, how we can do when this tension steel, or when both the steels are actually bent such that these two steels are merging at this point. At this point, both the tension steel and compression steel are passing through this midpoint. The difference or leverage between tension steel and compression steel is zero in case of this column. So at this point, the moment of resistance of this cross section of this RCC will be zero. So that is why I can, is moment of resistance is zero, and moment of resistance is zero. In such case, that at that point the material will act like a hinge. This is how we can make a RCC hinge in practical way. Now some people will also ask us, sir, okay, that is fine, can you show the Woods table how we can find out the effective length of columns in case of framed structure? Okay, let me show you that. Before I show you the Woods table, I just want to convey as a note, especially uh, this in Woods table, if you refer, in case of framed structures subjected to critical sway loads, okay, the effective lengths are based on Woods table as given in IS4. I already mentioned. And the Woods tables, the effective length of the column The effective length of the column is independent of load acting on the column. Whether the load acting is uniformly distributed load or magnitude of any magnitude, the effective length of the column is independent independent of load acting on column. The load acting on column is different, independent of load acting on column, right? And one more thing I can say, this effective length of the column is independent of load acting on the column. Moreover, I just want to convey one more thing. If you refer to effective length of the column, it is depend on length of column, span of beam, etc. But it is independent of load acting on the column. Now, I just want to show you how we can show a wood stable. This is how we can show a wood stable. Before I show the wood stable, from clause of appendix E. So if you refer to the appendix E of IS 456, refer appendix E of IS 456 2000, right? So the charts given in figure 26 to figure 27 of the code, if you refer to appendix E of IS 456 2000, the effective length ratio is separate for figure number 26 is for braced columns. To work out effective length of braced frames, effective length of columns in case of braced columns or braced frame, I can use 26, whereas figure number 27 is for unbraced columns, right? And coming to this beta 1, beta 2 will represent the degree of rotational freedom at the top and bottom end. Okay, how you can define this beta 1 and beta 2? Beta 1 is the uh, rotational degree of freedom. I can say indirectly the stiffness coefficient, the rotational stiffness coefficient at the top and bottom ends of the column. Rotational stiffness at the top and bottom. So if I want to, so some people had a doubt like, sir, what are these braced frames? What are these unbraced frames? Okay, let me tell you what is a braced frame and what is an unbraced frame before that. So what is the braced frame? Braced column or braced frame. If the lateral deformation of frame doesn't happen, in such case it is called braced frame. Or in other words, how we can define a frame as braced frame? Uh, I can say like when the top and bottom level of column doesn't have a differential sway, such case we call the frame as braced frame. Now, what is an unbraced frame? Unbraced frame we can call as braced. Because of this lateral loads or whatever that may be, when this frame structure is able to move sideways, the frame structure is able to move sidewards. In such case, it is nothing but unbraced. I just want to convey the effective length for braced frame and unbraced framed columns are separate. So I just want to show the sketches here. I mean, I just want to show figure number 26 and figure number 27 for you, from which you can work out this effective length. The effective length here, it's a function of beta 1 and beta. That means what? How we can write this beta 1 and beta 2, brother? Beta 2 and beta 1 by formulas. Beta 1 and beta 2. Either for braced frame, nose way, either for unbraced frame with the sway, I can say. In both the cases, beta 1 and beta 2, which we can write as sigma kc by sigma kc plus sigma k. Sigma stands for summation. What is this Kc stands for? Kc stands for uh, flexural stiffness of column. Flexural stiffness of column. You can work out when it is for beta 1. It is flexural stiffness of the column at top end, right? Stiffness Kc is flexural stiffness of column, and Kb is flexural stiffness of beam. Yeah, I just want to convey one thing. The flexural stiffness of beams or columns, it's a function of like when one end is fixed, another when a near end is hinged, when at the far end it is fixed. It's Kc or Kb, I can say. When far end is and I can say fixed, then Kc is equal to 4 by L. When far end is hinged, where you had seen this flexural stiffness of columns or beams in structural analysis program, especially in moment distribution method, you had seen how to work out the flexural stiffness of beams, and it is dependent on the far end conditions of the beams or columns. And the far end is fixed. The Kc is the flexural stiffness of column is 4 EI by L, and I can say when the far end is hinged, and far end is hinged. In such case, it is a 3 EI by L, and the far end is free. In such case, Kc is 0. I just want to convey one thing. Beta 1 and beta 2 are these factors, I can say, where what is this beta 1 and beta 2? Represents the degree of rotational freedom. Degree of rotational freedom at the top and at the bottom. So at the top, rotational freedom is called as beta 1. At the bottom of the column, it is called rotational freedom is beta 2. So which is sigma kc by sigma kc plus kb, where kc stands for flexural stiffness of the column and kb stands for flexural stiffness of the beam. So let us suppose if it is a non-sway frame, in such case if beta 2 is 0.5 for example, and beta 1 is also 0.5. Such case, clearly you are able to see the effective length will be between 0.675 to 0.7. So you can take effective length is between this one. So from these charts, definitely you are able to work directly the effective lengths very easily. Right? These were prepared by Woods. Directly we are working out the effective lengths of the columns in case of framed structures by using these charts. And beta 1, beta 2 formula using these ones you can work out. Beta 1 is at the top level and beta 2 is at the bottom level of the column. Right? Like then we can work out this effective lengths of column in case of framed structure. And also in framed structure there are two types of frame. One is with nose way, that is with nose way means it is braced frame. With without restraint against sway means it is a non braced frame. Is that okay, brother? Right? So please like our videos, share our videos, subscribe to our videos, brother. Right? So some people will say like, sir, I just want to say like what are these braced columns and unbraced columns. Here I had clearly given you the definition. In most of the cases, columns are also subjected to horizontal loads like wind or earthquake. If the lateral supports are provided at the ends of the column, the lateral loads are borne entirely by these lateral supports, and such columns are nothing but braced columns. Or in another way, how we can define this braced columns is when relative transverse displacement. Please see, when relative transverse displacement between the upper and lower ends of the column is prevented. Like if this is a frame, right, and it is subjected to some transverse loads, that upper and lower ends of the column transverse displacement is stopped with the help of a another thing called in this way. Even though when lateral loads were applied in this way, this frame cannot move to the sidewards. Why this frame cannot move to the sidewards? This frame was stopped by its lateral displacement, even because of this lateral load, because its lateral displacement is stopped by adding a beam which is fixed to this end at this fixed support. In this case, the lateral transfer will not move. This will not move. This will not move to the sideward direction. And in such case, the relative transverse displacement between upper and lower ends of the column. This lower end of the column. This is the upper end of the column. The relative transverse displacement between column is prevented. This is one way. In other words, how you can say it as a braced frame? Maybe instead of providing the same thing, is a braced frame. Like instead of providing it in this way, if I had taken a frame in this way, had taken the frame in this way, and to stop this lateral displacement or sideward displacement, there is we will go for bracings in this way. We go for these bracings, the lateral loads are resisted by these cross bracings. When the lateral loads are resisted by these cross bracings, the sideward deformation of the frame does not have. This is also an example for braced frames. I hope this type of elements are nothing but cross bracings. Especially in case of steel structure, the better way to resist the lateral loads is by providing bracings or cross bracings. The braced frame. Some people now will come and say like, sir, how we can mention about this unbraced columns, sir, unbraced frames or unbraced columns. In case of unbraced frames or unbraced columns, maybe I can show with the help of an example, right? Let me erase all the incomes. This is how I had taken a frame. Now to stop this lateral deformation of the frame, I didn't use any sort of bracings. Is subject to some lateral load. When it's subject to lateral load, is how the frame will sway. Like clearly, is how the frame will start deforming. This is how the frame start deforming. When from the bottom level to the top level, there is some transverse displacement, difference in transverse displacement there, right? So you can say this is a pretty good example for wave frame directly. This is a wave frame or unbraced frame. Uh, Unbraced frame, because the relative transverse displacement upper and lower ends of the columns is not prevented. With the upper end of the column and with the lower end of the column, the relative transverse displacement is there. It is not prevented. It is existing, right? In such case, the frame is subjected to unbraced frame, or which we call it as wave frame also, right? Shall I move to the next thing? Moving to the next one. And some people will say like, sir, what are the slenderness ratio limits for columns? I just want to convey, if it is a column, slenderness ratio limits for column, lambda of column should always be more than 3 and less than or equal to 60. Lambda of compression member, when it is less than or equal to 3, in such case it is nothing but pedestal. I hope you know lambda stands for slenderness ratio of column. The slenderness ratio of a compression member, it should always be less than 60. That is the thing. If you refer to 25.3 clause of IS, was clearly mentioned. So lambda of column is the effective length of column by least lateral dimension of the column should always be less than 60. So effective length of the column should be less than or equal to 60 times of least lateral dimension. Okay. And there is one more limit is there for cantilever columns, especially for cantilever columns. For cantilever columns, in case of cantilever columns, its unsupported length. If L is unsupported length should not exceed, should always be less than or equal to 100 b square by d. I hope you know, and this unsupported length in case of cantilever column is high. In such case, buckling is easier way. In such case, these columns cannot even resist even small magnitudes of axial loads. In order to stop that in order to make that cantilever column not to fail by easier buckling, this unsupported length should always be less than 100 b square by d. What is this b here? In case of column, if I take, b is the least lateral dimension and d is the depth. Generally, b is less than d, like that we can mention. So b is least lateral dimension, or is equal to width of cross section. It was clearly mentioned. What is d, brother? Depth of the cross section measured in plane under consideration. This is b and this is d. Like that we can easily work out. These are the slenderness limits for columns. Right? Both these two should be satisfied. Class 1 should be satisfied for every column, whereas this second class should be satisfied for cantilever columns. For cantilever columns or anything. One end of the column is unrestrained. So shall I move to the next slide? Moving to the next slide. In that slide, I will talk about the specifications of the stirrups of reinforcement. Specification of coming to lateral stirrup reinforcement. There are two things are there. One is lateral ties, and second one is, I can say, helical reinforcement. This helical reinforcement is the thing generally we use as this tie reinforcement, I can say, for circular columns. For circular columns. Whereas for columns other than circular columns, I can use this lateral tie. For columns other than circular columns. Right now, the question is, sir, what is the specification of the stirrups of reinforcement? These are stirrups. This is stirrup, this is stirrup reinforcement. The stirrup reinforcement diameter. If the diameter of this stirrup reinforcement, if P2 is the diameter of the stirrup reinforcement, diameter of the stirrup should not be less than 1 by 4 times of longitudinal diameter of the reinforcing bar. Longitudinal diameter of, what is the diameter of the longitudinal bar? The diameter of the longitudinal bar is P1. P1, diameter of longitudinal bar. I can write should not be less than 1 by 4 times of diameter of longitudinal bar. and the diameter of the stirrup should not be less than 6 millimeter. So it should not be less than 6 and should not be less than this one. Like that, we can fix the diameter of the stirrup. Moreover, you can see the distance between the longitudinal bars around the periphery. This should not be more than 300 also. That is also one more thing that we can see. Now, some people will come and ask us, sir, what are the specifications for stirrup reinforcement? Okay. In case of helical reinforcement, if I had used helical reinforcement, such case, what is the specifications that I can? Before I go to that one, I just want one thing. Here we can talk about what is this one. This is nothing but pitch of helical reinforcement, pitch of tie reinforcement, pitch of lateral tie. I want before I move to helical reinforcement clauses, I want to discuss about the pitch, the spacing of lateral ties. I want to discuss what is the maximum values for the pitch of lateral ties. At max, I can use. That's what I want to do. Now, if you refer to this class, if you refer to class number say 26.5.32 and page number 49 of IS 456 here clearly the screenshot directly I had taken directly from IS 456 2000. Coming to the pitches, pitch of lateral ties, pitch of lateral ties P, pitch should not be more than uh, least lateral dimension of the column. Least lateral dimension of the compression member is B. Least lateral dimension, and this pitch should not be more than 16 times the smallest diameter of the longitudinal. So phi of longitudinal bar I can phi of and there are two bars are there. I need to consider phi of smaller longitudinal bar and it should not be more than 300. This is about pitch, right? Whereas as per diameter, I had already talked about the diameter of lateral ties. Of lateral ties. Out of these three, what is the minimum one? I need to use that, right? Minimum I need to use. Now the question is, sir, 5. How we can talk about spacing, stirrup and helical reinforcement requirements in columns. If you take this left hand side is for stirrups, right hand side is the helical reinforcement. So for helical reinforcement, if I want to talk, now coming to this helical reinforcement, this is how the stirrups will be there. I mean, this is how the helical reinforcement. Now you can take this is the pitch of helical reinforcement, right? This is the pitch of helical reinforcement. The pitch of this helical reinforcement should not be more than 75 millimeters. Pitch of helical reinforcement should not be more than 75 millimeters. The maximum one. And minimum one it should not be less than 25 millimeters. And this pitch of the helical reinforcement should not be more than 1 by 6 times of diameter of core concrete. I hope you are able to small d. Where small d stands for diameter of core concrete. How you can define this diameter of the concrete? Diameter of the concrete which is inside the helical reinforcement. That diameter is diameter of core concrete. And this so let me write here. Pitch for helical reinforcement. Helical Emax maximum pitch not be more than 70 millimeter, should not be more than 1 by 6 times of diameter of core concrete. Diameter of core concrete for helical reinforcement. Now some people will ask us, sir, okay, Is fine. What is the minimum pitch for helical reinforcement? The minimum. The minimum pitch for helical reinforcement should not be less than 25 milliliters. This for helical reinforcement. Be very clear. Helical reinforcement. And it should not be less than three times of the diameter of the stirrup. Not be less than three times of of stirrup. Diameter of helical ring. Oh, this is about maximum pitch. This is about minimum pitch. This is about maximum pitch of helical reinforcement. Okay. If you can see the same thing from SP30 of IS 1897 also. In the time of detailing, how we can do the detailing, we can see the same thing from page number 18. Right? Is that okay? So yes, for today, brothers, as the time is almost more than 1.5 hours. For today, I am just stopping the session. Yes. Before I stop this today's session, I just want to convey again. There is paid courses are also there in Unacademy Learning App. If you are a serious aspirant of GATE or ESE or any other competitive examination, I can definitely recommend you to take the paid course. And coming to the paid course in plus courses, the cost for this 12 months duration of subscription in plus course after 10% discount is 27,220. Okay, and moreover, the cost for this 24 months duration of subscription after 10% discount in plus course is 39,600. I can say one thing. This 12 months duration of course I can recommend for the students who are in year, whereas I can recommend this 24 months duration of course for the students who are in, I can say for the students who are in second year and or third year. Even for working professionals also, I can recommend this 12 months course or 18 months course. Okay. For any of the course duration, either maybe 6 months, 12 months, 18 months, or 24 months, or even 1 month also, I can say like the cost is the cost to get 10 percentage discount. I mean, if you want to get 10 percentage discount, you are bound to use this code VT10 referral code. When you are able to use this faculty referral code VT10, directly 10 percentage discount will directly come to you on all the courses in Unacademy learning app, in Unacademy Plus platform. So in such case, you need to download the Unacademy learning app, brother. Right? And moreover, I just want to convey every day my class is happening. This Let's Crack GATE and ESE Civil YouTube channel. My class is happening every day by 11 a.m. So if you are an aspirant to crack GATE, ESE or any other competitive examination in civil engineering, I can definitely recommend you guys to come down to my class, and also to Kamlakar sir Pandey's classes also. I can recommend you. This class every day is happening by 9 a.m. And moreover, last but not least, one thing I just want to say, you are all getting this for free of cost. So please share our videos to your friends so that they will also get benefited from these free video lectures, because for this free video lectures there is no need to pay even a single penny. It is the free content that we are providing. And moreover, if you are able to raise a thumbs up, definitely with more energy we can do more free content for you in the nearby future. One thing, when you subscribe to our channel, when you press the bell icon, not even a single video you will miss from our channel. In such case, you will get each and every content that is delivering from this channel, which will be helpful to you to crack any sort of competitive examination, at least with a few concepts, right? Last but not least, if you are a serious aspirant of GATE or ESE, if you want to take the paid course, use this code VT10 in Unacademy learning app, especially in plus courses, to get 10% discount. When you use this code VT10, directly it will connect between you and me. Directly, it shows your trust on me. It shows your faith on me. And it will provide 10% discount for all the courses in Unacademy learning app. ranging from 6th standard to PG standard also. If you want to get any 10% discount for your friends or your family, you are free to use this code VT10, brother. Right. When you use this code VT10, I will take care of your entire preparation in civil engineering. One thing. And you will be, and I will be your personal mentor when you are able to use code VT10. Right. And moreover, uh, for you guys, I already started a Telegram group to resolve your doubts. And the name of the Telegram group is Let's Crack GATE and ESE. And one more channel also, Telegram channel I had started for you. The name of the Telegram channel is Unacademy underscore Civil Engineer Tilak. If you want to come down to my channel, use this link which is given below. When you use this link, when you press this link, you guys will be redirected to my channel. You are able to post your doubts and I will take care of your doubts definitely. Right. So some people will say like, sir, that is fine. Okay. And one more thing I just want to convey. There is an academy gate combat is happening on this month, December 16th. So you please write those examination and there are more prizes are also available for you. So don't forget to register now for an academy combat. If you write those examinations, you will understand at what level you people are. Na? So on December 16th, an academy combat is happening. You can register in an academy learning app by using the code combat now. And you use this code combat now, you are able to write the examination for free of cost. And moreover, there are so many prizes are there, brother. Don't forget this one, right? You will be provided with prizes of laptops and tabs are also there. You can write the examination. Moreover, you can check at what level you people are and compared to the topmost students of an academy. You can check your performance. Okay. So thank you very much. End of the session for today.